Page 267, we're going to learn the FOIL method and distributive method for combining two fractions that have variables in them. The example 3x over x minus 2 equals 3x plus 10 over x. Let's cross multiply these. 3x times x gives us that first term, 3x squared. The x minus 2 times the 3x plus 10 are two binomials, and from the FOIL method we're going to combine those. So look on the second column here, and we're going to walk through this. So FOIL first, outsides, insides, and lasts, and we're going to combine or multiply 3x times x, the first, the outers, 3x times a minus 2, the inners, 10 times x, and the last terms in each of the binomials, 10 times a minus 2, giving us a minus 20. We combine all of that and put it towards equaling the first term, 3x squared, and we end up with, if you look at the first column, 3x squared equals 3x squared plus 4x minus 20. Take away 3x squared leaves us with 0 equals 4x minus 20. And x equals 5 as our solution. Go ahead and finish the 3 problems. You might want to use some extra paper for this, or there's some back note paper in the back of the book. Okay, good luck, and we'll move on. Page 268 and page 269 are about factoring. Factoring uses greatest common factors to simplify expressions. Now, what we're going to do here is the first thing we're going to do is prove that factoring works. So if you've got 4x plus 8x, we've got 12x. Now, if you look back at the expression 4x plus 8x, you have to ask yourself, what is the greatest common factor here? And the fact is that 4x is the greatest common factor. It's shared with 4x as 1 and 8x as 2, leaving us with 4x times 1 plus 2. 4x times 3 equals 12x, thereby proving it. So let's go on to example number 2. The first example is pretty simple. Greatest common factor of 6x plus 2 is 2, so we factor out the 2 and multiply it to 3x plus 1 over 4. Now we've got 2 times 3x plus 1 over 4, and 2/4 can be reduced down to 1/2, leaving us with 3x plus 1 over 2, and that's the factor. Now on page 269, we've got 3 terms, 3x cubed, 9x squared, and 6x. We can't combine like terms because there aren't any. However, we can factor out the greatest common factor that they each of those terms share, which is a 3 and an x, because they each have an x. Couldn't do that if they didn't all have x's. So the first term 3x cubed, second term 9x squared, third term 6x. We distribute out the 3x, leaving us with x squared plus 3x plus 2. And with that, we can go on and factor the following expressions. 6x plus 6, that was a very similar one to page 268. And then this one here, where we don't have similar terms, is a lot like 6x squared plus 6x. Someday soon, as you can see, we'll start working on quadratic factoring, but this is not part of this particular book. But we'll eventually get there. Because of this kind of work, you'll get there easily.